Hello everyone, my name is Raj Venkat Reddy Mauram and my teammate's name is Ashwant Kumar Kundeti. We are here to present our semester project in the course CS536. So without any further ado, let's get started with it. So starting off with the agenda, we'll begin with an introduction discussing about the project, followed by the project overview. We'll then move on to the application walkthrough, where we'll see how the application works and the flow, and finally ending with a quick demo of the application. Our project is essentially an Android application called Voice-ChatGPT, and as the name suggests, instead of giving the prompts to ChatGPT via the keyboard, the user gives it in the form of a speech, and the response from the ChatGPT is also in the form of a speech for the user to hear. You might be wondering, what's the need for such an application? Which in all rights is a valid question. And the simplest answer to that would be that the application addresses the need for a more accessible, natural, and innovative way for users to interact with their Android devices and also to address the growing demand for seamless and user friendly interactions with technology, especially in the realm of mobile applications. Before we delve deep into the technical aspects of the project, let me talk a little bit about the primary components involved in the project, namely the ChatGPT, the speech to text, and the text to speech integration. So, starting off with ChatGPT, what exactly is ChatGPT? ChatGPT is a language model developed by OpenAI and is designed to understand and generate human like text based on the input it receives. It excels in natural language understanding, enabling it to engage in coherent and textually relevant conversations with users. Trained on diverse and extensive datasets, ChatGPT can be utilized for a wide range of applications, including content generation, language translation, and conversational agents. Moving on, speech to text technology enables the conversion of spoken language into written text, facilitating efficient transcription, voice commands, and real time translation. As an integral component of natural language processing, the speech to text systems leverage advanced algorithms and neural networks to accurately interpret and transcribe diverse spoken inputs, with applications spanning from transcription services to voice activated assistants. Speech to text plays a pivotal role in making spoken information accessible and actionable in various domains. Next, the text-to-speech implementation typically involves the integration of dedicated APIs and libraries that convert written text into natural-sounding speech with some well-known frameworks including Google's text-to-speech, Amazon's Polly, Microsoft Azure's text-to-speech, to name a few. These frameworks employ advanced neural text-to-speech models, generating high-quality synthetic speech that closely mimics human intonation and pronunciation. In our application, we use text-to-speech to convert the response from ChatGPT into a speech for the user to hear. Moving on to the program overview, and also now that we have gained some knowledge about these components, let's move on to this section. In this section, I'll be talking about the programming language used, the frameworks, libraries, and the APIs for creating the application. I'll also shed some light on the STT and TTS integration, which would be explained by Ashwant in detail while he discusses the application walkthrough section. Oh. Starting off with the programming language, we use Python end-to-end across the entire application to maintain consistency. Python as a programming language is well known for its simplicity and readability. Additionally, Python's extensive ecosystem offers robust libraries for both STT and TTS functionalities, which streamlined our development process and ensuring seamless integration of these critical components. The speech recognition module in Python is a powerful and versatile tool for integrating the speech-to-text functionality, which is one of the primary components in our Voice-ChatGPT application. The speech recognition module provides interface to access various automatic speech recognition engines such as Google Web Speech API, Sphinx, etc. The PyTT-SX3 module stands out for its simplicity, cross-platform compatibility, and it also has support for multiple text-to-speech engines, making it an excellent choice for the project. It is a straightforward API which does not require extensive configuration in order to use making it very user-friendly. And moving on to the OpenAI module, the OpenAI module in Python provides access to the OpenAI REST API services. For the project, in order to make use of the OpenAI API, we had to create an account in OpenAI and then create a secret key, which is to be used as the code for authenticating the OpenAI API access. And finally, the socket programming. It is a crucial aspect of the client-server architecture and communication in networked applications. It facilitates communication between Android application and the ChatGPT server, wherein the Android application being the client and the ChatGPT being the server. So socket programming also enables the establishment of a reliable and efficient communication channel between the client and the server. So Ashwant will speak more about the app walkthrough and all, and end it with an application demo. Over to you, Ashwant.
Let's do an application walkthrough right now. So first the user sends his speech through the app, which is recorded at the app side. And then we use the STT integration, which is the speech to text integration. We use the speech recognition API for this, which uses the underlying Google API to translate the speech to text. This is then used by the client side app to then send it back to the server. The server processes the message that is received from the client and sends this back to the ChatGPT API. The ChatGPT API, as we normally see, provides an answer for the client query, which is then sent back to the server. The server would reply this back to the client as just a text message, and it is also done in chunks to ensure that there is no network traffic between the client and server. The client uses the text-to-speech integration, which we use the PyTTX X3 library for this. This then converts the text message that is received from the OpenAPI to back to speech, and the Android application gives it back to the user as a speech. We'll try to take a look at the various scripts that we use for each of these APIs. So this is a client-side application, and the main heart of the client side lies in the record function, which converts the speech that it recognizes from the user back to text. So we use the speech recognition as I mentioned before, and we also make use of threading to ensure there's some parallel computation, which reduces the time complexity to compute the whole speech to text. We then send the message back to the server using the client. We also split up the message into chunks to reduce the network traffic. We currently use a packet size of 100, which we have found through our testing that is the best appropriate and the best packet size. So after the client sends the message from user back to the server does all the processing. The server receives the user query from client in form of the text. The server then sends this text query back to the ChatGPT API. The ChatGPT API processes the user query and generates an appropriate response. This response is then sent back to the server. The server processes the response from ChatGPT and sends it into chunks to the client. The client would then send this back to the user application, and the user application would then use the text-to-speech API, which uses a PyTTSX3 library for that. And the user would then listen to the appropriate answer that was generated from ChatGPT. Let's move on to the demo.
Hi, tell me a dad joke.
Sure, here's a classic dad joke for you. Why don't scientists trust atoms? Because they make up everything.
What is the capital of India?
The capital of India is New Delhi.